Hello, everybody. No, I'm sorry, I don't have Cat today. All three of them are out in the store attending important business. Nobody wanted to hang out here back with me. They have very important things to do. Hi, everybody. So today we have an A1707 that has no power. I don't think we have any more description from the customer, just that it's not turning on anymore. So let's just dive into it. So here I already took the back cover off. So the first thing we're going to start with a quick visual inspection. Doesn't seem to be any liquid anywhere, any green stuff, any sticky stuff anywhere on the thing. So we're going to start with a function check. Disconnect the battery. Always start your check with the battery disconnected. And then I'm going to take my amp meter, connect it to a, I think it's an 87 watt power supply, a regular Apple 87 watt power supply. So I'm going to plug in, let's start with this one here. Okay, nothing. That does absolutely nothing. I will flip over the charge cable, plug it back in, absolutely nothing. Okay, this one. Okay, we got something, 5 volts, 400 milliamps. Okay, something shorted. 400 milliamps is too much at 5 volts to be taking, so something shorted on the board. Let's see if we could narrow it down a little bit more. We'll try the other two on the other side. Cord's kind of short. Cord's really short. Okay, 5 volts, 400 milliamps still. 5 volts, 400 milliamps. Okay, so 3 ports are doing the exact same thing, and 1 is doing something different. So this port, 5 volts, 400 milliamps. This port does absolutely nothing. So one of these things is not like the others. One of these things just doesn't belong. So let's find out, let's open up the schematic and board view for this port right here, or this board, and we'll find out what this port goes to. Just open up my software for an A1707. Okay, bring you over to the schematic and board view. So here I have my software open, my wonderful Paul Daniels software, and this is the side of the board that we're looking at. So this is a butterfly view of the board. You're seeing the top and the bottom. So this is what's hidden from our view with it still in the case. This is what we can see, where we can see the CPU and GPU. So if I zoom in here, we're working on this little arm right here, and this is the charge port connector. So this one was the one that, this side of the charge port connector is what was giving us 5 volts at 400 milliamps. And then this bottom part of the charge port is giving us nothing. So I want to find out what chip this goes to. So I find this is the best one to go to, the CC1. CC1 or CC2, either one of them. You find this USB-C XB CC2. USB XB CC1. This is the charger communication line. So I click on that, and that's going to show me exactly what chip it goes to. Oh, it goes to this chip right here, the one that we can see. So this is the side of the board that we can see. So this is the charge port we're looking at, the bottom one, and this is the chip that's in question. So I figure this chip is going to be shorted. So let me zoom in on this here, see if I could show you this in a little bit wider view. So this chip here, when I plug this in to the one that's somewhat working, I get 5 volts at 400 milliamps. So I bet this chip is getting hot. And I'm going to display that without using the $1,000 FLIR camera. I'm just going to take a Q-tip. I'm going to rough it up a little bit in my fingers so that it like puffs up so it'll hold more alcohol. I'm going to dip it in the alcohol. Okay, my pumper bottle's not working. It's usually Lewis's problem. There you go. He hates those pumper bottles. Mine always works. His never works. Okay, now I have a lot of alcohol on this tip. I'm just going to cover this chip in a big drip of alcohol. And we're going to plug it into the side that works. You see that alcohol immediately evaporate. If I unplug it, you see the alcohol just spread back out. So we can see that that is what's getting hot right away. It gets hot, and I could stop it from getting hot. It's not just evaporating because it's warm in here. It is evaporating because that chip is getting hot. So that's the chip we're going to go after. So I have to remove this board from the machine. Some people would be okay soldering with this in the machine. I don't like doing that. There's very few things that I won't take the board out for. But this chip takes a lot of hot air to get the thing out, so I don't want to solder this in the board, or in the machine, so I'm going to take the board out of the machine. Dusty fans. This is a little bit dusty, yeah, there is some dust in there, but this is not that bad. These things are just like vacuums. It's unbelievable how much dust a MacBook can hold, and this is not that bad. This is average. Okay, first I'm going to go around the whole board and take out all the T3 screws. So I have my Wow Stick 1F with the T3 tip on it that I've color-coded. It's fading, but I've color-coded all my tips because they all come the same color. It'd be great if they were some of the ones that are close to the same size. It's hard to tell the T3 from the T5 sometimes, or the T3 from the PL1 or PL4. So just keep going around, take out all the T3 screws. Here's the display connector. Keyboard connector. So how's everybody doing on this hot New York Friday? It is currently 81 degrees outside. We have 3 rather large split air conditioning systems in our store, and they're having a hard time keeping up. Your igloo melted. It's bad. 83 in Maine. You're supposed to be colder up there in Maine. You're close to the frozen north. So my 81 isn't that bad. What's the wristband? This is the Samsung Fit 2, the new Samsung Fit. Really cheap. I've had this thing for like 2 years now. It's working great. I love it. Okay, that should be all my... Oh, nope, I missed the 2 board screws. So most of the T3 screws are just the connector caps that are holding down the connectors and stuff, but then you have 2 board screws that are T3. No SSD on an A1707. There's lots of different things that can be wrong with that. Are you sure it's no SSD or just no operating system on it anymore? Like when you boot external, it's not showing you an SSD at all. These SSDs like to burn out, so... By the water in Brooklyn, it's 71. Wow. 10 degrees cooler being by the water. Okay, that's all the T5 screws now, so we're going to go to the last size, T8. And that's these 2 heatsink end screws, or T8. Okay, now we start disconnecting connectors. So I already disconnected the touch bar, the left charge port. Now this is the microphone. This is the other touch bar connector. I have a speaker here. Lift straight up on the speaker. It's good to, it's not good to, but you remove it by pulling up on the wire. Don't try to shove your screwdriver or tweezers underneath it and rip it up. People rip these connectors off the board all the time. You just lift up on the wire and it comes off. The Wi-Fi antenna ones, just pop them up from the metal of the connector close to the wire. The display connector, just lift straight up with a fingernail. Same with the keyboard and the trackpad. And again with the speaker, pull up the wire is taped down, so that's what is the hardest part of getting this connector off is the tape. So you slide your tweezers underneath the tape and just lift up on the wire, comes right out. Then we have the this is the headphone connector, and then the power button is this little guy hidden under here. One more charge port. Okay, that's everything. Now I'm going to unstick the gaskets here from the fan. The gaskets will come out with the heat sink. You want to unstick them from the fan. And just start lifting a corner with a fingernail. Get underneath there, wiggle the board as you go. It'll show you what's holding you back when you wiggle it. Just a little bit. There you go. We have a logic board. Okay, so this is what we're going to look at here. I want to look at the other side. Actually, I would like to look at the charge port itself. That's a good thing to inspect, is to take out the charge port itself. Let's look at this charge port. Change back to T5. Now these screws are different than everything else. They don't match anything else, but they look a lot like other ones, so don't mix them in with your other ones. They're really hard to tell apart, and nothing else will fit. Okay. Oh, I see the problem here. Okay, this is an issue that I've seen a lot of actually. So let me show you this underneath the microscope. When you buy cheap adapters, presumably it's the ones that are like double adapters, and they're like an I/O port expander. They have a couple, like an HDMI port and a couple regular USB ports. I think it's those. It could be just about anything that is doing this to your charge port, but they're too tight when they plug in to your charge port. And this is what's happening to everybody's charge ports with these cheap adapters. They're actually ripping the pads apart. They squish the pads and cut them apart until they're all connected together. Eventually, these things are going to be connected together and just shorting everything out and killing. Yep, there you go. Look at that. It tore the metal. It squished the metal until it tore off, and it connected I think that's going to be the negative and the positive, possibly. That's a ground, but then the longer one, I think, is the negatives, because you want the ground to connect first, and then the shorter ones are data and positive power. Or vice versa. Maybe that is the negative. I need to look at a pinout again. I haven't seen that in a while. But I think the big one at the end there is the negative, and then the next longer ones, the two that are messed up, those are the positive, because you want negative to connect first, then you want positive, and then you want data. So it looks like the positive power, the 20 volts, got shorted to this data pin right here. That's what happened here. And I'm thinking that this is going to be a charge cable. This is just a non-Apple original charge cable that did this, because it only did it to the negative, positive, the charge controller, the CC. So that's CC1 or CC2 right there that's ripped up, and it's connected to the positive. So that's what killed this CD, this charging chip that we're going to change. So there's no point in getting knockoff charge cables. Like I hate saying that, but Apple makes a really good charge cable. They do make a good charge cable, and it's not that expensive. It's long, it's tough. Just get the Apple original charge cables for your stuff. I hate to say that. I've never seen any good ones, and this is what you get when you're buying non-Apple original. It does this to your charge port. See, this one that hasn't been used as much, but it's still showing the same wear. This is how it starts. And then that's how it ends. So because of, well, actually no, since it was, the other side had more things connected. This might have been one of the little dongles that plug into the side of it. Let's check the other side while we're at it. They probably use this one more often, but let's see what the other side looks like. This might need 2 charge ports on top of the logic board repair, and then a warning to the customer to stop using what they're using. Okay, this one doesn't look like it's cut up, but it does have some liquid damage in it. Oops. No? Uh-oh. Okay. So this one's liquid damaged. Which, that's not that bad. There's no burning on this, so this can be cleaned up, but there is the scoring from the accessory, whatever accessory is being plugged into this. This one would be okay, though. It's not that bad, but we'd probably wind up changing this, too. I don't think I want to send the customer home with it scored that much. Like, half of this pin is missing right here. So yeah, we're going to wind up 2 charge ports. 2 charge ports and a logic board repair for this machine. So, onto the logic board repair. Let me find another magnet for those screws. I don't have any magnets here. Okay, I will just have to be careful with the way I place this. Okay, so this is the chip we're going to go after. Okay, so let's just check around. I'm pretty sure that that's going to be the only problem, is that charge port, that accessory has murdered this chip. There's some dirt around here. We'll wind up doing a dusting of the board before it's all done. Let's change out this chip. So let me turn on my fume extractor. This is going to be a lot of soldering. I'm going to add a little bit of flux to this chip. Take some hot air, which my hot air is always set to full and full, whatever the machine can do. So this machine is 120 liters of air and 500 degrees centigrade. I gotta watch this, there's a plastic connector right above here for the microphone. I want to try not to burn that. So I'm going to direct the air a little bit away from that, more towards the can chip, because the one in the can's not going to hurt. There you go. The chip came off nice and easy. Didn't hurt the connector. Now we need to clean off the board. So the first thing I'm going to do is take my large soldering iron And I'll add some new solder, some leaded solder to this. I'm just absorbing all of those lead-free solder balls. I do this because the lead-free is a pain in the butt to wick off the board. So now that I've got rid of most of the lead-free and there's all leaded solder, now it'll wick off really easily. Clean off my tip a little bit more. Okay, now we're just going to use some wick and pull all the remainder of the solder off the board. Now this did more damage than I was hoping. So I see the one of the pins there has come off the board, and I think that's going to be for the CC1 or CC2, whatever took that 20 volt hit from the charger. It blew the entire pin away from the board. So we're going to have to repair that. Let's see what it looks like on the bottom of this chip. Which way does it go? So if it went that way, that's what we're looking at. Yeah, these aren't even like solder anymore. You see how everything else melted kind of nicely, came off kind of nicely, but this one, it's like all gravelly, and this one's a big old flat mess. Because this stuff got overheated, it got welded, and that's why we're missing the trace right here. So we're gonna have to rebuild this trace. Okay, I want a little bit thicker jumper wire than what Lewis has here, so let me go get a piece from my desk. One moment, please. I am back. Okay, so now rebuilding. So let's inspect the area. What do we have to do here? Build a plan of attack. For what are we going to do here? So it's just one trace. It connects to two balls. Let's scrape off. First thing we got to do is scrape off this. We'll put some solder on here. I think I'm just going to do just a wire straight through here. I'll come out a little bit farther so that when we green it, we could glue it down here. There's nothing here underneath the chip, so I don't have to worry about clearance issues. So yeah, I'm just going to solder a wire straight through here. And then once it's down here, I'm going to flatten the wire out a little bit where the two balls are going to go onto it. Some flux. I'm going to be using my micro iron. Got some solder there. Got my jumper wire. Okay. It's not completely flat to the board, so I gotta hit it one more time. But I want to hold it flat up against the board. Are these my tweezers? Yes, they are. There we go. Nice and flat. That looks good. Crazy how small and precise you have to be. What can how can I describe what I'm working on? Let's go to the overhead. So you can see the area I'm working on here, this little square. Let's zoom in on this camera. This one doesn't really get close enough for you to even see the wire I'm using. So this is the wire I'm using right here. You can kind of see it hanging out there. What's a good, I don't know, a Q-tip. Yeah, everybody knows how big a Q-tip is. It's like the tip of my finger. So let me show you that under the microscope. So what I'm working on is this area right here, and that's the size of a Q-tip. So like you see like the hair of a Q-tip is half the size of what I'm working with. So double the hair on a Q-tip, and you got the piece of wire that I'm working with. Get that in good focus. You can see the one little hair of Q-tip that's hanging out here, and the hair of a Q-tip is maybe a third of the size of the wire. So yeah, this is small stuff we're working on. Okay, so the wire is in place. So the next thing I'm going to do, I'm going to go take this out to the ultrasonic cleaner. We're going to clean it off real good. Now, let me wick those couple of pads off that I put some solder on. Let's get that clean first. Okay. So yeah, I'm gonna go clean this off in the ultrasonic cleaner, and then we're gonna put some conformal coating over this to make sure it stays in place, and then we'll try to flatten out the two pad areas a little bit. I'll have to grab my dental tool too for that. So, one moment, please. Hello. Okay. So now we're nice and clean. It's covered in alcohol right now, so I'm going to just dry that off real quick. So there's our little, what's going to be new pads. First I want to do is cover the ends in some conformal coating. So I have my UV curable mechanic conformal coating. Just going to use my dental tool, like a little pen. I'm just going to do a drop right here. I'm going to do a drop right here. get that right down the center of those pads. That looks good. Bring this up a little bit more. Okay, now I'll cure it with a near UV light. Just takes a couple of seconds of UV light. And clean off my tweezers, and now we'll try to make some flat pads for this to connect to. So this should be nice and solid here, yep. Get that right in the center. And I'm just going to use the flat side of my dental tool, and we're just going to flatten this wire out a little bit. Right where the two balls are going to land on top of it. I went a little too hard there. I broke my conformal coating. It's okay. I'll just scrape that out of there and redo it. As long as I don't break my wire off, we're good. Copper's very malleable. Okay, make sure it's nice and flat. I gotta get two hands in on this, so clean off my tweezers. I don't want any flux getting on this. This flux will keep the conformal coating from sticking. So, some nice clean tip tweezers. I'm gonna hold my pad down. I'm gonna bend this back down to the board. There we go. I'll put a new drop on that side. That looks good. Cure it. Okay, now there's one other thing that I'm worried about when you make these. When you have to replace pads, I'm always afraid that because of the surface tension of the solder and how small we're working on, is that it might have a tendency, the balls that are going to be landing on these two smaller pads now might have a tendency to get bulbous and connect with something alongside of it. So what I'm going to do is create a dam of conformal coating all the way around this. So I have a lot of conformal coating on this this dental tool here. I'm going to make a little pool on this capacitor next to me. I'm going to use that like an ink well for the really skinny side of my dental tool. See the puddle that I made there? Is that in focus? It just looked up. Okay. So I'm going to dip the tip of my tweezers in there, or my dental tool, and just draw a line right between everything. So the conformal coating like repels solder when it's dried. Solder does not want to stick to this. It makes it ball up away from it. So having this like this will ensure that the balls that are landing on these two new pads are going to stay right there. They're not going to bubble out or anything. They're not going to combine with anything else. I'll cure that. Light's too bright, I can't even see what I'm curing. There, much better on my eyes. And now this is curing with light, so I'm going from the right to left. Now I want to go from left to right too, so that there's no shadows. Not completely necessary with this little bit, but you know, there could be a shadow on the other side of that wire underneath everything that's staying liquid. So you want to get every angle. Make sure everything was touched by the near UV light. Okay, now we'll lightly clean that up. Be very gentle. We don't want to rip up our wire. I'll clean up my pool that I put. There you go, we have 2 new pads. What happens if the coating is too thick? If it's too thick, Hey Sonny, how's it going? If it's too thick, it won't cure underneath. Up against the board will stay liquid, and it's only the first maybe 1/4 millimeter or so that will actually cure. So you have to put it. If you need thick conformal coating with this UV conformal coating, you have to put multiple layers. You can't just try to go to one thick layer, or else it'll never cure underneath. Higher power UV light. We use these near UV lasers. They're like absolutely terrible. All of them, like the sale has been curtailed on eBay a lot. They're above the maximum allowable wavelength or power. I mean, like this says it's a class 2 laser product, less than 5 milliwatts. This is probably a class 3 laser product, and it's less than 10 milliwatts. It's not 5 milliwatts. But this is all you need really, because it gives you the really small point, because that's all you're curing. That's all you're actually putting on this thing is a tiny small point ever, and it cures it very fast, because you're not going to get any light, any flashlight that's stronger than this little point. All the UV LEDs are nowhere near as powerful as this in such a tiny spot. But you just there's handling precautions with this, you know, don't look at it. Don't look into it. I try not to look in my microscope when I'm using it. The glass lenses should filter out most UV, and by the time you're seeing it, you're only seeing the blue lights of the phosphorescence of anything that you're hitting with. We tried the UV CFLs. We bought the nail drying things, those little things you put your hands in at the salon to dry not nail polish, but the tips that women get on their nails. Forget the chemical, the plastic, resin, whatever it is that they put on. Acrylic, that's it, acrylic. And they're inconvenient, they're big, they're annoying. You have to have like a desk to go to for it. Like this is just a pen. It's perfect. Okay, we're ready for a new chip. So I went and purchased some chips from store.rossmanngroup.com. And I have a brand new CD3215 for this. Store.rossmanngroup.com for chips, flux, supplies, all shipped same day from New York City. So first we need to look at orientation. How's this going to go on here? So we have a dot that indicates pin 1, and if you're in the know, you know that missing, this little missing ball over here also indicates pin 1. If we look at the bottom of the chip, you see the missing, so we're just going to put it so that missing one goes right on there. That's how it goes. So the missing one is pin 1, that's how it's going to go. And if you see, you look at the bottom of this, see where my bump is. It's a pretty big bump right there that the corner of the chip's pointing to. of the conformal coating, but there's nothing on the bottom of the chip to get in the way of it. That's just going to be in a void, so it's not going to affect anything. I'll just put the chip next to where I'm working on. We'll get some flux in there. When I flatten the wire, what about the enamel coating on it? Flattening it should have removed the enamel coating. I mean, I could double check that and make sure. Get really tight in there. Let's make sure that enamel coating is off of there. So yeah, just scraping this and flattening this. Oops, I still have some green on here. Clean that off. So I can see, oh, does this come across camera? You can see that the conformal coating is peeled away on this side of the wire. If I focus, you fuck. Let's get all the way in. Focus on that. Let me get some better lighting. And I bet you guys can see this. It's tinted green now because I just put some green on it, but you can see this white flake of stuff to this side of the wire. That is the conformal, or I mean the enamel coating that's on the wire. It is flaked off. And you can see I'm making actual marks in the copper itself. This one is already tinned, because when I soldered here, it tinned a little farther down, so there's definitely no coating on that. So yeah, that should solder just fine to that. Okay, a little bit of flux right in the middle. There, I did a Lewis amount of flux. Set the chip in it. Push the chip down. Try to get it centered. Wiggle it around a little bit. Since I have those new holes for the pads and everything, it's not going to move much. That seems about right. Maybe a little down farther. Okay. Just hold it down very lightly. It moved. I wasn't holding it down enough. Hold it down lightly as the flux heats up and moves away. Okay, it moved into place. I can make it dance. I see other things melting around it, so it should be good. Okay, now we will do some rapid cooling. Just put the board right in the fume extractor. Cool that off real good. How do you know if you overheated the IC? That's a question. I guess from experience for me, but how do you tell when you're starting out if you overheated the IC? If stuff farther away from what you're soldering has melted and moved, then you've probably overheated the IC. So when I was soldering this chip right here, I saw that the bottom half of this capacitor here melted. So when I saw that melt, then I'm absolutely certain that the whole board in this area is hot and that chip is soldered on. I was also moving my air like this, and you could see the chip wiggle a little bit on top of its pads. So then I know it's done. And if I went farther than that, like if I heated it up enough where this actually slid over, or even worse, the second capacitor over here melted and slid over, I probably overheated my chip. A lot of the chips you can see discolorations get on it if you overheat it. What made it move into place? So the surface tension of the melted solder balls. As soon as that lead melts, it wants to congeal with the pads. So you have the pad here and a solder ball that's like hanging out. Let me zoom out. So you have like I'm looking at a cross section. We're looking at the board like this. If I have the pad here and I have a solder ball that's here on the edge of the pad, once it gets melted, it wants to grab hold of this pad and pull over. Because it wants to grab hold of this pad, but it still wants to grab hold of the pad that's on the chip, so the whole thing just moves the chip over. So that's one of the ways you know that you soldered it in place, that the chip is sitting here, and all of a sudden you see it moves right over. Then you can make it dance a little bit. You know it's on top of the pads. Everything's melted in place. Oh, I didn't bring my charge port. Dang it. Be right back. Okay, so I got my extra charge port from my bench. Put that on there. I could turn off the fume extractor. We don't need that noise now. So I have my charge port is on this side. So this is the side that was giving us 5 volts at 400 milliamps. So let's see what it's doing now. 5 volts at 20 milliamps. And we got 20 volts. It's not turning on yet, though. There it is. 1.46 amps. That's a 1707 turning on. And we plug into this one. This is the one that was dead. That's going to this chip that I just put on here. Negotiated 20 volts. And it's turning on. So now we also, in our function check, we also need to check, so that was either CC1 or CC2. We have to check the other one. So I flip my charger upside down. I plug it back in. Because one of those was destroyed. And there you go. The charger communication line's working again. Both ways, both sides. And the machine's turning on. So there you go. We took a A1707 with no power. We diagnosed that one of the CD3215s was bad, was shorted out. We saw that it happened because of the ripped up charge port connector. Let me show that again for anybody that just tuned in. This was the fault. This is what killed this this little chip here. This is the charge port. So this is an okay looking charge port right here. This is what your charge port's supposed to look like, a little bit worn out. Shouldn't be that deeply scratched. And then we go to this one here. And the pins for the charge port have been ripped apart by some accessory. And it's connected the positive to the charger communication line. Zoom all the way into that. You see the pin has been ripped apart, and a piece of it is touching the other charger pin. So the big pin that's ripped apart, that's the positive connection. Because the negative connects first, then the positive connects, and that's probably the CC, the charger communication pin. So that's what blew this up. So then we discovered the one CD3215 that was bad. We take it off, and we see that this charger port also destroyed the traces underneath the chip. So that sent 20 volts right to something that's supposed to have just a communication line on it. That's why it exploded like that. So we just changed that, rebuild one pad, and we're up and running again. So I hope you learned something. Hope you all have a good day. Wonder if anything else is blown with that voltage. Good question. It is something to look into. So we look at here. Oh, there is something else that we should check on. Good question. So this is the CC1, this is the CC2. One of these was burnt out. Let's actually find out which one it was. It was this one. It's the one we're already looking at. So this one was fine. This is where I put my wire coming right through here. So this is what was blown out. Now this capacitor could have been hurt. Let's see what the rating is on this capacitor. It's a 16 volt capacitor. Let me bring that on screen. So it's a 16 volt capacitor, and this thing saw 20 volts from the charger. So that capacitor, I should probably change that. That capacitor is going to come off the machine and get changed. And then what else? There's this diode right here. So this is a clamping diode for static protection. So this probably is blown up. I wouldn't be surprised if we look at that and it's actually charred. Let's take a look at that. Good day. Good coffee. Awesome. Thank you. So which one is this? This is... Let's go back to the schematic and board view. We're looking at... It's the bottom section of these capacitors and diodes, and it's the second one from the first break. So not this one, the next one down. So let's go back to the board itself. So that's what we're looking at, and we're looking at the two black boxes there. So these diodes are meant to handle a lot, so that looks good. It would be burnt up or popped off the board or something if it was bad. That looks just fine. And let's take a look at that capacitor up there. The capacitor looks fine too. Yeah, there's no scorch marks anywhere or anything. It looks good. So, good question. Yes, always, when you find out a cause like that, always take a look at what else is on the that line. What else could have possibly suffered damage? My apple is a lemon. Yes. Yes, don't buy a 1990 or 2141. If you have one of them, keep backups. Their hard drives love to kill themselves. Keep backups. Okay. Have a good day, everybody.